Hello viewers and welcome back to the lab. This is part 5 of the Quantel DPB-7001 restoration series. There has been a fair amount of progress made since my last video, so I wanted to give you a bit of an update because it's been a few weeks. Now I want to thank my patrons as ever for their support. The money that they put into the pot is helping to get this machine up and running, and as you'll find as I go through this particular video, it looks like I might have to start spending a bit of money to actually sort a few things out now. If you want to chuck any coins into the hat, then follow the links in the video description. So in the end of episode 4, I managed to boot this system using the original Brush Master floppy disk, but that was only a brief usage of the machine. I didn't want to use this floppy disk because we don't have the hard disk running yet. It's continually trying to access this floppy disk, so I can't keep using that. So at the end of that episode, I was talking about using a Gotek, and I have indeed now got a Gotek here. That is all connected up with a bit of homebrew wiring. I will show you that in a bit more detail in just a moment. There have been a few other issues that have happened along the way, not particularly major ones. Tablet started throwing out some really bizarre issues. I would get the pen in a particular position and it would start, like the cursor would just like zoom off somewhere. The cursor was really jittery. That turned out to, I think, be just some old capacitors. So those were replaced. There was about 9 of them, all tiny little electrolytics. So that was easy to hopefully fix. The problem seems to have gone away. So hopefully that will stay problem-free. The other issues I had were on the Computer 2 cards. I've been dogged with issues on those 2 cards right from the beginning, and I remember having this running and it just suddenly crashed, locked up, and I couldn't get it to boot again. It literally, it was back to the original problem of the bus errors when you turn it on. So that was a bit frustrating. But if I just open the door here, I spotted there was 3 capacitors missing off this board, so the power distribution wouldn't have been good. And I also found 2 EEPROMs that had gone bad. For one of them, I literally just reprogrammed it and it seemed to be absolutely fine. It's possible that just needed reseating. The other one went bad just like the one previously, so I've had to replace that with a new chip. But since then, fingers crossed, it's all been pretty good. I'll probably live to regret saying that. Now I think what I'll do, I'll move the camera around a little bit. I'm going to give you a bit more of a look at some of these components because you've probably not really seen them in that much detail previously. So now the system is becoming a bit more usable in that I can literally have it here set up. I can turn this on and I'm pretty confident it's all going to work. So it allows me to sort of relax a little bit from repairing stuff and actually start showing you a little bit more detail about this machine. So as you can see here, I've got it sort of semi-permanently set up now, just so I can continue working on it. We've got the big tablet. That is a tablet which is manufactured by TDS here in the UK. This was introduced on the DPB range in the mid-1980s. They had originally released the DPB with a summer graphics tablet. So I think what it was, they managed to sort of refine it and switch to a different maker of tablet. So that's why this tablet doesn't look quite like the ones you see in those early videos. Underneath we've got the 8-inch floppy drive. This was standard issue for the DPB. That is a double-sided, double-density drive. Stores about 1.6 megabytes on a disk. And we have the keyboard for the system. Nice ticky-tacky keys there, with a connection through to the tablet, because that, as you learnt on the previous episode, that all gets merged together and sent down one single serial cable. We have the classic DPB tablet pen with what it is actually, it looks like there's actually a ballpoint tip in the front there, which is used to actually make contact with the surface. I'm probably need to get that under a microscope just to see if that really is a ballpoint pen that's had no ink in it. So yeah, very classic design. You remember seeing these in some of the early videos. Weirdly, this actually gets warm. The tip here, there's some RF coils in, which is used for doing the tracking. So the tip of this actually gets warm. It's quite weird. The other amazing thing about the pen is I actually have a spare one. It really is kind of remarkable that I've managed to acquire this, but I do actually have a brand new unused spare pen for a classic paint box. Remarkable. Now, as you can see here, I've got a Gotek Floppy emulator. So this was kindly donated to me by Stuart. So thank you very much, Stu, for supplying that. This is running Flash Floppy, the latest version, and I've got, quite appropriately, a Quantel USB drive there holding the disk images. Now, the other thing that has happened since the last video is my CryoFlux has arrived, and that allowed me to connect this up to the 8-inch floppy drive and get another image of that brush master disc. I had tried the ones that I'd made quite a few years ago, but since I ran that disc for a couple of times booting this machine, it seems to have got better. It's almost like using it has cleaned it a little bit. I was actually able to get a pretty good image of that. That is now written onto the USB drive as a HFE file, and it works pretty well. There are some issues using this Gotek on the DPB. I'm not quite sure exactly what's causing them. I have spent a bit of time looking at this and trying to figure out what the issue is. I haven't really got anywhere, and it's probably not something I'm going to worry about too much. I'll go into that a little bit later when we start talking about the hard disk. Now, given that we are still using a floppy drive, although it is an emulated one, the system is still quite slow, as in when you swipe off the menu or bring up the palette, it has to access the brush master files which are on the image, and that does slow things down quite a lot. As I said in previous episodes, there would have been a hard disk attached to this system, and those swipes and that would have instigated those brush loads would have been very, very quick indeed. You would have hardly even noticed them, to be honest. But here with a floppy drive, it is a bit of an issue. It does slow things down a little bit. And right here we have the actual paint box itself, and you can see that I've now reattached that front panel. Now I'm working on this a bit less. I figured it would be a good time to get that reattached. So given that I've been working on this for several weeks now, running through the service manual, which has been invaluable, I've gained a lot more knowledge about this machine than I ever previously had. Some of the details I might have said in the original teardown that I did a few years ago, they might be wrong. So I thought it'd be nice just to go quickly through this. I'm not going to go into massive detail, but I thought I'd run through the different cards in this and just give you a more updated view of what those cards actually do. So if we open up the front panel here, so you can see we have a load of vertical cards up at the top section. Those top section cards are mostly digital processing. There is a couple of analog ones, and that's the output timing and the output processor card. Those are the ones that actually generate the actual video. In the bottom are all the video input cards. So we have a decoder card here, which does the PAL decoding, along with the ADC card. And at the bottom, we've got input locking. Those aren't plugged home at the moment. As I said on the last video, I need to make some repairs on them. I think it was the input locking card. There was some tantalum caps on here. One of them shorted out, which blew this inductor here. So that is on order, and I'm going to replace the other one as well. And replace the capacitor that went as well, and hopefully we can plug that home and we won't have any more magic smoke escaping. There was also some capacitors which blew on this card as well. So those need replacing. So given that I've only been working on the none of the video input side, I thought, well, I might as well just not have these cards plugged in and we can just leave them as they are until I get around to looking at them. So the top cards, as I said, are all digital, or mostly, apart from the video output ones. We have computer 1 and computer 2 here. So those are the Motorola 68000 based computer, which runs all the software, and that connects to the rest of the cards, or most of them, through a 16-bit bus, which is the 68000 data bus. The address bus from the 68000 is not connected to the rest of the cards. The way it addresses them is through a special register called the CSR. Allows the computer cards to latch in commands onto the cards and then pass data to them through the 68000 data bus. So first card along, we have the digital interface card. I didn't really know what this card was way back, but I do now. This is a later addition to the DPB. What this allows you to do is to import and export images and cutouts, things like that, and actually transfer them digitally. Now the way it does that is quite clever. Instead of having a pure digital connection, it actually uses a video connection, but it's actually a fully encoded system which allows a paintbox to talk to another paintbox, or a paintbox to one of Quantel's other systems, like their digital library store, which was a store of still images. So if you wanted to transfer an image from the paintbox into the store, you could do it digitally, which meant you didn't lose any video quality. And it's the digital interface card which allows you to do that. The good thing is I have a full technical reference to this standard. Well, it's Quantel standard. So there is a good chance we should be able to, with a little bit of creativity, be able to get images in and out of the paintbox digitally further down the line. Next along, we have the disk sequencer and disk buffer cards. These two are the SMD interface cards, which allows the computer to talk to hard disks and floppy disks. So the disk sequencer is a little processor board which sends the commands out to the peripherals and says read track 23 side A of the floppy drive, say, and that track is read out and then stored in the disk buffer, where it can then be sent to one of the other cards, or it can be read by the computer cards. Next card along is the filter. That is a special card. Don't have a lot of information on this because it was like proprietary Quantel stuff. That does all the filtering, as in the filtering, so when you're resizing an image you don't get big pixelized pixels, and when you shrink it down you don't get aliasing and all that. So that's the filter card. Size control, it works with the filter and the brush processor cards to just be able to resize bitmaps. The brush address, brush store and brush processor cards are responsible for containing the actual brush which you're painting with, and a load of other functions as well, things like doing fills and things like that. So that's all handled by those cards. Input timing, this is the card that generates the timing which clocks the entire system. And then we come along to the store cards. So these are the frame stores. This is where all the image data is stored. We have a store address card there and another one here, and we have two stores. The reason we have two stores is one is your main painting screen, and the other one holds the things like cutouts and the menu, which isn't normally on the screen. So that allows you to have the on-screen display plus some storage in the background, if you like, that you can use. So I believe these three cards here are for the main display, and these three here store things like the menus, the palette, and any cutouts. The next card along is the combiner, and that's quite a critical card because it takes all of these cards and combines them all into one single thing, and that's the video output. So that then sends the output of all that digital data to the output locking and the output processing cards, which actually produce the video signal itself. Now, I'm actually considering making some slight changes to this particular card. I didn't really want to start modifying this machine, but there is some rather helpful things that I could do to actually make this a little bit easier to live with. Is the video outputs to this. There's two types of video output. There's RGB and sync, and there is also the composite PAL. The composite PAL is what it is. That's absolutely fine. It's just not great quality. If you want the best quality, then you want to use those RGB outputs. The problem with those is the era that this was made, you generally didn't have composite sync, and that means you'd have RGB, but the sync would actually be embedded into the green channel. That became a lot more common as time went on, and it means a lot of modern equipment kind of expects to have a sync on green. So if you have like component video, for example, which is YUV, you'd often have the sync on the Luma channel. That represents a little bit of a problem for me because all my video scalers, they're not RGB plus sync, they're all RGB and expect to have an embedded sync on green or sync on Y input. So what I might actually do with this is actually put a slight modification board onto this, which will give me a composite sync on the green channel, so I can actually plug this really easily into a video scaler, and it's something I can probably do without really modifying the board at all. If I do that, that'll be on a future video. Right, so before I turn this on, I just want to mention the video capture that I'm getting off this is actually composite PAL video, so it's not going to be the best quality until I get that sync on green issue sorted out. I would rather just capture composite PAL. The only way I can capture the full quality at the moment is to actually run it through my Paintbox Express, and that means having another Paintbox on, and it's already getting pretty warm in here. So let's turn this on. And it will begin reading the floppy drive. Now I do see a few errors with this Gotek. As I said before, I'm not entirely sure, and I'm not really that fussed because when we get a working hard disk, I generally won't need to use the floppy drive anyway. So there we've got the white screen. It's still booting up, it's still reading those brush master files. And eventually I'll get on my screen up here, which you probably can't really see at the moment. I'll get a message saying the system is ready to use, and there we are. So if I just turn over, so we have now the cursor. So because we're using the Gotek now, this makes things so much better. I don't have to do things in a rush, and I can actually show you a little bit more. So if I swipe off, now I should say that occasionally the files don't read properly off the Gotek and will get corrupted menus. It's literally just a visual thing. The Paintbox carries on regardless. If I swipe off and swipe back, it'll reload and it'll work. So I don't think there's any real issue there. I suspect that problem will go away anyway when we get our hard disk emulator. So we've got the normal Paintbox menu. There's a few things which are different, which I hadn't really noticed before. There's no secondary store on the classic Paintbox. On the later machines you had a store, picture 1 and picture 2, that you could switch between. This doesn't have enough frame store memory in it to be able to do that, so you only get the image that you're actually working on. So generally everything seems to work. If I swipe off, we should be able to paint. If I swipe down, we bring up the palette, and this is where those little delays come in from using that Gotek floppy drive. You can switch up to the larger brush, wait for it, swipe off, and there we have the normal paintbrush. You can switch to different colour. Switch to the different brushes, the chalk brush. So this is the largest size. Now you might not be able to see this because I am capturing, as I said, the PAL video, so it's not going to be greatest quality, and you might get a bit of shimmering effects that you get from a composite PAL signal. We also have the usual airbrush. I'll change that to 100%. If there's one brush which is going to fail to load properly, it's probably going to be this one, so we'll be interested to see whether it has loaded it properly. Yes, it has. If it doesn't, you get a load of weird graphics on it. It just looks like all corrupted. Just like those corrupted menus, if I just swipe off and back on again, it'll reload and it'll be absolutely fine. So that's the airbrush. So as you can see, it's pretty. You have to think that this was released in 1981. It's just absolutely staggering, the type of thing that you could do back then if you had the money. So we also have the stencils, which I didn't show you before. So we can draw a stencil. Oh, see that? We have corrupted menus. So when it loaded the text brush to generate the menus that time, it all got a bit horribly wrong. So that's what's causing that. So if I swipe off and then back on again, I bet you any money it'll be absolutely fine. Yeah. So we can draw stencils. So let's just do standard paint. So that's drawn a stencil. Now we can actually turn that off. We can use it, go to airbrush, and we can now paint through that stencil. So all these functions working absolutely fine. In the graphics we can do lines, so let's just change to a smaller brush. We'll turn off the stencil. Actually, I'll tell you what, we'll reverse the stencil. We'll keep using it. And we'll pick a different colour. We'll pick black. So we can do rectangles. Oh, there's some more corrupted menus. As I said, the machine just carries on regardless. Do rectangles, and we can also fill those if we wanted to. Well, if we could read the menus. So what is probably easy is just to swipe back off and then on again. And it will probably read the menus just fine again. There we are. So solid. So you have your basic sort of rectangles, lines, circles, ellipses and all that sort of stuff that you've seen on paint boxes previously. In effects, quite a limited set of features here. Colour map and mosaic. There's some effects which I might show you in the future. Not really worth going into just yet. Paste up. This is one part that I haven't actually managed to get working. One of the issues I have with the Gotek is it doesn't seem to want to be able to write any information. And when you cut something out, it gets written to the disk. Now normally that would be the hard disk, but we don't have that. We've only got the floppy drive, which means because I can't write anything to this disk, it just gets corrupted. I can't show you the cut and paste features until we actually get a working hard disk. That's probably going to remain a bit of a mystery. Also, I can't generate any text because I can't load any fonts onto the system. So again, until we get that working hard disk, it's going to be difficult to show you any of that. The library is where you go save and load pictures. Now unfortunately I can't do that either because A, the images get corrupted anyway because I'm writing to the disk, and the brush master disk doesn't have enough room to store the brush master files and a picture, so it's all become very, very limited. So as you can see, we're making real progress on this. As I said in that when I was showing you around the system, the biggest issue now that we need to resolve is the hard disk. Now we can't use the original one because it's just too big. I mean, it weighs 50 kilos, it's 14-inch platters. It's just not practical to use this in any way going forward. So we need some kind of emulator to emulate that drive. Now, I've already started talking to a few people about what a potential solution might be, and we're getting some pretty good ideas on where we might actually end up going with this, but it's going to be a little bit dependent on how much time and effort people can put into this. It's not something I can do, unfortunately. I would love to be able to go away and work on this for a few months and come up with my own working SMD hard disk emulator, but sadly that's not the case. I like restoring this old stuff, but my skills only go so far. So this is going to be somewhat dependent on help from others. It looks like we're probably going to have to do our own thing. There are a few other SMD emulators. Some of them aren't working, or some of them are commercial or extremely expensive. So we're probably going to have to roll our own thing. The current thinking for us at the moment is to replace one of the cards which is actually in the back of the machine. I've only really shown you the cards that sit at the front, but there are two which live at the back, and that provides the electrical interface for the SMD bus. So they convert the TTL logic, which is generated on all the digital cards here, all the standard logic, and converts that to ECL differential, which is used over the actual SMD wiring. Now, if we're going to replace the SMD disk, we don't need to be working with the SMD electrical issues, so that card could actually be removed and replaced with an emulator. That is our current thinking at the moment, so how far we go on that, I don't know. That will probably be an update for a future video. There are still a few other little jobs that I need to do. Firstly, one thing I've realised is the power light doesn't come on. I've no idea why, so that's something that's going to need to be investigated. There are the repairs to those video input cards that I need to do. There is also a grounding wire which is deep in the back here. That, when I had to fix that backplane issue where it was not in the right place, I found this link and it didn't really, if I plugged it in the place where it looked like it should go, it was a dead short on the 5-volt supply rail, so I just removed it. Now I know where that is supposed to go. That is something I also need to fix, but I'm going to have to take a huge portion of this apart again to refit that. So that needs to be done. As I said before, I also want to look at doing a slight modification to that video output card to give me sync on green, so I can capture the video at the best quality it possibly can be. You never know, even in the future we might be able to have something in this which will give us digital video. That would be a very nice addition, but not massively necessary. So I think the setup of this might be in the future, if we can get that hard disk emulator, is that we will literally just have the Paintbox crate, the tablet, the keyboard and the pen. We'll be able to do away with the floppy drive. We won't need that because we'll be copying the brush master files off the Gotek onto the hard disk, which will be internal to the machine. So I think overall it'll make a nice, really, I can't say compact, but it'll be more compact than it should be, because we won't need an external hard disk, we won't need the external floppy drive, unless we want to try and read some actual floppy disks. Right, I think that pretty much wraps it up for this update. Hopefully, I'm keeping my fingers crossed that as the whole global pandemic thing goes on and we can actually get this machine out to some shows and stuff and actually get people been able to play around with this, because it's a lovely piece of equipment to use. Until you've actually used one, you don't quite appreciate how cool they are. So it'd be nice to get this out to some retro and classic computing shows for people to experience. Right, thanks very much everybody. I'll see you on the next video. Bye for now.